When people think about tanks in World War II, Japanese armored vehicles are often overlooked or dismissed as inferior compared to the massive steel monsters fielded by Germany and the Soviet Union. Japanese tanks appeared small, lightly armored, and outdated, yet this perception hides a deeper and more complex reality. Japanese tank armor was not designed to compete directly with Western heavy tanks. It was shaped by geography, doctrine, industrial capacity, and the unique nature of warfare in the Pacific and Asia. From the very beginning, Japan approached armored warfare with a fundamentally different philosophy. The Imperial Japanese Army did not expect to fight large-scale tank battles across open plains. Instead, it prepared for operations in China, Southeast Asia, and the Pacific Islands. Environments dominated by jungles, mountains, narrow roads, and limited infrastructure. In these conditions, mobility, reliability, and transportability mattered far more than thick armor. Early Japanese tanks such as the Type 89 Igo reflected this mindset. Their armor was thin, often just enough to stop rifle fire and shell fragments. Against modern anti-tank weapons, it would soon prove disastrous. The Type 95 Hogo, one of the most widely produced Japanese tanks of the war, embodied both the strengths and weaknesses of Japanese armor philosophy. Its armor was extremely thin by European standards, with flat vertical plates offering minimal protection. Even heavy machine guns could penetrate some sections of the tank at close range. However, the Hogo was light, fast, and mechanically reliable. It could be transported easily, crossed weak bridges, and operated in terrain where heavier tanks would struggle. Japanese tank designers were well aware of their armor limitations, but they faced severe constraints. Japan lacked access to large quantities of high-quality steel and advanced alloying materials. Naval construction consumed a massive share of available resources, leaving the army with limited options. Every millimeter of armor added increased weight, fuel consumption, and strain on engines that were already operating at their limits. As the war in China intensified, Japanese tanks encountered stronger resistance, anti-tank guns became more common, and infantry tactics evolved to counter armored vehicles. In response, Japanese engineers introduced incremental armor improvements rather than radical redesigns. The Type 97 Chiha, for example, featured slightly thicker armor and a more robust hull design, yet the basic philosophy remained unchanged. Protection was still secondary to mobility and production speed. Unlike German or Soviet designers, Japanese engineers did not embrace sloped armor early on. Most Japanese tanks used flat plates, which offered limited effective thickness. This was partly due to manufacturing limitations and partly due to doctrine. Japanese commanders believed tanks were primarily infantry support vehicles, not armored duelists. As a result, armor was designed to resist small arms fire and shell fragments, not high-velocity armor-piercing rounds. The Pacific War exposed the consequences of this approach. When Japanese tanks encountered American forces equipped with modern anti-tank weapons, their armor proved almost useless. Even light anti-tank guns and handheld weapons could disable or destroy Japanese tanks with ease. Side and rear armor were especially vulnerable, and internal layouts offered little protection against spalling and internal fragmentation. Despite these weaknesses, Japanese armor design was not entirely stagnant. Later models such as the Type 1 Chihi and Type 3 Chinu featured improved armor thickness and better steel quality. These tanks represented a late attempt to modernize Japanese armored forces and address the growing disparity with Allied tanks. However, by the time these vehicles entered limited production, Japan's industrial capacity was collapsing under bombing and blockade. Another critical factor influencing Japanese armor was logistics. Tanks had to be transported by ship across vast distances. Weight limits were strict, and heavier armor directly reduced the number of vehicles that could be deployed. This logistical reality reinforced the preference for light armor and compact designs. A lightly armored tank that could reach the battlefield was considered more valuable than a heavily armored one that could not. Crew protection was also affected by internal design choices. Japanese tanks often lacked adequate internal spall liners or protective features. Ammunition storage was poorly protected, increasing the likelihood of catastrophic explosions after penetration. Ventilation and fire suppression systems were minimal, further reducing survivability once armor was breached. Japanese tank armor during World War II was therefore a product of compromise rather than ignorance. Engineers understood the limitations of thin armor, but they operated within a strategic and industrial framework that left little room for alternatives. Armor thickness alone could not solve the challenges Japan faced, and attempts to increase protection often created new problems without delivering meaningful battlefield advantages. Understanding Japanese tank armor requires abandoning comparisons based solely on thickness. These vehicles were not designed to fight panthers or tigers. They were designed for a different kind of war, in different terrain, against different enemies. When that context changed, Japanese armor design was exposed as fundamentally mismatched to the realities of modern armored warfare. As the Pacific War intensified, the weaknesses of Japanese tank armor became increasingly impossible to ignore. What had once been a calculated compromise between protection, mobility, and logistics turned into a critical vulnerability as Allied forces adapted rapidly. American troops did not need heavy tanks to defeat Japanese armor. Even basic anti-tank weapons, field guns, and improvised tactics proved devastating against vehicles that lacked sufficient armor thickness and internal protection. One of the most significant challenges facing Japanese tank armor was penetration from unexpected angles. In jungle warfare, engagements were often close-range and chaotic. Tanks were attacked from the sides, rear, and elevated positions, where armor was thinnest. Flat vertical plates offered no deflection, allowing shells and projectiles to penetrate with minimal resistance. Even when penetration did not occur, impacts frequently caused internal spalling, sending fragments of metal through the crew compartment. Unlike German or Soviet tanks, Japanese armored vehicles rarely incorporated design features intended to mitigate spalling. Internal surfaces were bare steel, and there were no dedicated spall liners or protective coatings. As a result, even near misses could incapacitate crews. Survivability depended less on armor performance and more on avoiding direct contact with enemy fire. A dangerous strategy as Allied forces increased their firepower and tactical coordination. Steel quality further compounded these problems. Japan struggled with consistent access to high-grade steel alloys throughout the war. Naval construction and aircraft production received priority, leaving tank factories with lower quality materials. Armor plates often lacked the optimal balance between hardness and toughness. In some cases, armor was too soft and penetrated easily. In others, it was overly brittle and prone to cracking or shattering on impact. Both outcomes reduced real-world protection regardless of nominal thickness. The attempts to improve armor thickness introduced new difficulties. Japanese tank engines were relatively underpowered, and suspensions were not designed to handle significant increases in weight. Adding even modest amounts of armor reduced speed, reliability, and off-road performance. In environments where mobility was already restricted by terrain, these losses were unacceptable. As a result, engineers were forced to limit armor upgrades to incremental changes rather than comprehensive redesigns. The Type 97 Cheiha, one of the most common Japanese tanks, illustrates this dilemma clearly. Its armor was improved slightly over earlier models, but not enough to withstand modern anti-tank fire. The tank remained vulnerable to American 37mm guns, bazookas, and even concentrated machine gun fire at close range. Field reports consistently describe Japanese tanks as easy targets once detected, reinforcing Allied confidence and reducing the psychological impact of armored assaults. Japanese doctrine further limited the effectiveness of armor improvements. Tanks were primarily viewed as infantry support tools, not independent armored units. They were expected to advance alongside foot soldiers, suppress enemy positions, and provide mobile firepower. This role did not prioritize armor survivability against enemy tanks or anti-tank weapons. When Japanese tanks encountered American armor or defensive lines equipped with dedicated anti-tank assets, their armor offered little protection. In contrast, Allied tank doctrine evolved rapidly. American forces emphasized combined arms operations, integrating tanks with infantry, artillery, engineers, and air support. Japanese tanks, lacking both armor and coordination, were often isolated and destroyed systematically. Armor thickness mattered little when vehicles were outmaneuvered, outgunned, and attacked from multiple directions simultaneously. Late-war Japanese tank designs attempted to address these shortcomings. The Type 1 Chihi introduced improved steel quality and slightly thicker armor, while the Type 3 Chinu featured a more powerful gun and better frontal protection. These tanks represented a recognition that existing armor philosophy was inadequate. However, production numbers were extremely limited. Industrial disruption, resource shortages, and Allied bombing prevented these vehicles from being deployed in meaningful quantities. Even in these later models, armor design remained conservative compared to Western standards. Sloped armor was still minimal, and internal protection measures were largely absent. Improvements were incremental rather than transformative. By the time these tanks reached operational units, the strategic situation had deteriorated beyond recovery. Armor improvements could no longer influence the outcome of the war. Another overlooked factor was crew training and experience. As the war progressed, Japan lost many of its most experienced tank crews. Replacement crews received limited training and had little opportunity to practice armored tactics under realistic conditions. Proper use of armor requires skill, angling hulls, using terrain, coordinating movement. Without training, even the best armor performs poorly. In Japanese tanks, where armor was already minimal, the impact of inexperience was severe. Japanese tank armor also suffered from inadequate recovery and repair capabilities. Once a tank was damaged or immobilized, recovery was often impossible. Spare parts were scarce, and specialized recovery vehicles were limited. A tank disabled by track damage or minor mechanical failure was effectively lost. Armor that could not prevent immobilization offered little long-term value. The psychological effect of weak armor cannot be ignored. Japanese tank crews were aware of their vulnerability. Accounts from the field describe crews operating with caution, knowing that a single hit could be fatal. This awareness reduced aggressiveness and limited tactical options. Armor that inspires confidence can shape behavior. Armor that fails repeatedly undermines morale. By the later stages of the Pacific War, Japanese tanks were no longer viewed as a serious armored threat by Allied forces. They were treated as secondary targets, easily neutralized with available weapons. This perception further reduced their battlefield impact. Armor that fails to command respect loses its deterrent value entirely. Japanese tank armor during World War II thus represents a case study in how strategic assumptions shape engineering decisions. Designed for one type of war, in one set of conditions, it proved disastrously inadequate when those conditions changed. The armor was not poorly designed in isolation. It was poorly matched to the evolving realities of modern warfare. Understanding these failures is essential to understanding why Japanese armored forces collapsed so quickly when confronted by American industrial power and technological adaptation. Armor alone cannot compensate for inferior doctrine, limited resources, and an inability to respond quickly to changing threats. By the time Japan recognized the need for fundamental change, it was already too late. By the final years of World War II, Japanese tank armor had reached the limits of what it could realistically achieve within Japan's strategic, industrial, and logistical constraints. The problem was no longer simply thin armor or outdated designs. It was the complete mismatch between Japan's armored forces and the type of war it was being forced to fight. As Allied pressure intensified, Japanese tanks became symbols of an earlier doctrine that no longer applied to the realities of modern mechanized warfare. Late-war Japanese armor development reflected urgency rather than long-term planning. Engineers attempted to improve survivability through modest increases in thickness and limited material improvements, but these efforts were constrained by collapsing supply lines and industrial disruption. Allied bombing campaigns targeted factories, transportation networks, and steel production facilities, further reducing Japan's ability to manufacture consistent armor plate. Unlike Germany or the United States, Japan lacked access to diverse raw materials and could not easily import high-quality alloys. As blockades tightened, material shortages worsened. Armor steel became increasingly inconsistent, varying from batch to batch. Crews could never be certain how their tank's armor would perform under fire, eroding confidence and reliability across armored units. At the same time, Allied forces had fully adapted to the weaknesses of Japanese armor. American infantry units routinely trained to counter Japanese tanks using coordinated fire, terrain advantage, and combined arms tactics. Tanks were rarely engaged alone. Anti-tank guns, artillery, aircraft, and infantry weapons worked together to neutralize Japanese armor quickly and efficiently. In this environment, even a significant improvement in armor thickness would not have changed outcomes meaningfully. In static defense roles, tanks were often dug in or used as fixed firing positions. While this reduced exposure to flanking fire, it also eliminated mobility, one of the few advantages Japanese tanks still possessed. Fixed tanks became predictable targets for artillery and air attack. Armor designed for movement offered little benefit when vehicles were immobilized by design rather than damage. The contrast between Japanese and Allied armored recovery capabilities became increasingly stark. Allied forces invested heavily in repair, maintenance, and battlefield recovery. Damaged tanks could often be recovered, repaired, and returned to service. Japanese forces lacked this infrastructure. Once a tank was damaged or abandoned, it was usually lost permanently. Armor that failed to prevent initial damage therefore represented a complete loss of investment rather than a temporary setback. Crew survivability remained a persistent issue. Japanese tanks provided minimal internal protection once armor was breached. Fire suppression systems were rudimentary or absent, increasing the likelihood of catastrophic fires. Escape routes were limited, and internal layouts offered little protection from blast effects and spalling. Armor failure often meant total loss of both vehicle and crew, reinforcing the perception that tanks were expendable assets rather than platforms designed to preserve trained personnel. The psychological impact of ineffective armor cannot be overstated. Tank crews operate best when they trust their equipment. This awareness shaped behavior, encouraging caution, defensive positioning, and in some cases reluctance to engage. They were designed for a regional war with limited mechanization and weaker opposition. When that context changed, the armor philosophy collapsed. Incremental improvements could not compensate for a fundamentally outdated doctrine. In contrast, Allied armor development benefited from industrial flexibility and rapid feedback from the battlefield. When weaknesses were identified, production methods adapted quickly. Armor layouts were revised, materials improved, and internal survivability features enhanced. Japanese industry, constrained by geography and resources, lacked the capacity to respond at the same pace. Armor development became reactive rather than proactive. By the end of the war, Japanese tanks were largely irrelevant to the outcome of ground combat. They were overshadowed by air power, artillery, and infantry-based anti-tank tactics. Armor thickness, once a defining characteristic of armored warfare, had become secondary to coordination, logistics, and technological integration. Japanese tanks, designed for an earlier phase of warfare, could not adapt quickly enough to remain effective. The legacy of Japanese tank armor in World War II is therefore not one of failure in isolation, but of limitation. It reflects a nation fighting beyond its industrial means, attempting to adapt outdated systems to a rapidly changing battlefield. The armor itself was not poorly engineered for its original purpose, but that purpose no longer matched reality. Understanding Japanese tank armor requires acknowledging these constraints rather than judging it solely by comparison with Western designs. It serves as a reminder that military technology must evolve alongside doctrine, industry, and strategy. Armor cannot compensate for deficiencies elsewhere, and no amount of steel can replace the ability to adapt. In the end, Japanese tank armor tells a broader story about the nature of modern war. Success is not determined by isolated technical features, but by the integration of technology, production, training, and strategy. When one element falls behind, the entire system suffers. Japanese tanks entered the war designed for a different battlefield, and they exited it as relics of a doctrine that could not survive the pressures of global, industrialized conflict.